Hey fellow genies, Fletch here. During this talk I'll cover a lot of technical terminology and even have a twist hidden agenda by the end. But a lot of the talk will follow the theme of hiding complexity. Before I get too in-depth, let me first address hiding complexity by addressing how complexity is rooted out. And much like a hog looking for roots to eat, sniffing and puffing his nose through the dirt, a developer looks for something called code smells. A code smell is like a stinky cheese. Many times, the cheese has begun to grow mold and you need to make a serious change or throw it away. But every once in a while, that stink is on purpose. So even if you find a stink, you leave it alone. The problem really comes when you put your cheese inside of some hidden container that hides the smell and you forget about it completely, allowing it to poison your system with mold spores, but not letting the smell out. That is hiding complexity. Code smells are a developer's friend, and some code is stinkier than others. For a quick aside, I want to talk about feature gating. It will come in useful later in the talk. Feature gating is an integral part of any system. There are three types of feature gates: authorization, time, and environment. Just like input validation, feature gating happens in each layer for its own reasons. But there are typically two main locations. One is in the UI for user experience, and the other is on the API for safety and security. So most developers have at least seen feature gating with authorization. That is, an admin can obviously see a button or menu item, while a non-admin cannot. Therefore, the key to that gate is a role or permission on the user's auth token. It isn't too uncommon also to have a time-based feature gate. You want to wait for Christmas banners to pop up? Write your JavaScript to check for the date time and then show all kinds of Christmas-based HTML. Want special deals to only happen on that day? Write conditional business logic, or completely lock down the API, to call different algorithms or parameters during a configure timeframe. More on the development side and less relating to the customer, there are environmental feature gates. Given an environmental variable, probably changed in the config transform, you can show or don't show a feature on the user interface. This way, a feature can actually be pushed all the way to production, but a user would never know it exists while QA is reviewing, demoing, or testing it in test or dev environments. It's a common mentality throughout my talk that you should be able to push an incremental part of a system all the way through to production, even if the rest of the feature isn't complete yet. One easy example that you may already use is adding to a database. If I'm developing a new Christmas specials table in dev, it is 100% acceptable to add that table to the production database, even before the feature is being tested in a dev or test environment. Of course, you don't just go having random thoughts and then doing them in production, but you can see how an incremental approach has no drawback if there's no negative effect. Developers communicate with each other through the stories we write in our code, and when we read each other's code, we get insight into the other's personalities and skill levels. Some code is written like a monster truck, where a developer may be hiding some insecurity. Some code is written like a rusted-out 1992 Corolla, with one spare tire on the front wheel, missing headlight, smoke pouring out the back. Some code is written like a new electric vehicle. They've been around a long time, but for some reason, people are still supporting the oil industry. That's a different subject altogether. When I work with developers or read their code, I judge their skill level based on what I see. Imagine a developer writing dirty code. Not obviously buggy or broken, just not using statements, more than one or two empty lines between methods or execution, indentation all messed up, orphan variables, misspelled variables or method names, unused using blocks, and other things most Visual Studio plugins will point out and possibly fix for you. These are intern level mistakes. If I see this in code, my impression of a developer is that they are new to communication via their code. So I try to instill a sense of pride in those interns. If a developer has been in the game for 5 or more years and they are still writing messy code, I subconsciously assume that they don't have a desire or an ability to keep up with the world of development. Unfortunately, there are a lot of developers who are never told this directly. Developers at large aren't great with confrontation. So it is frequently the case that these developers don't know that they need to grow in this area. If you break any of these rules, or you don't know what I'm talking about, either you are an intern, or you owe it to yourself to go look at the points I cover as soon as possible. You officially have no excuse to be writing code like an intern, you've been told. Of course, I understand that we can't all be software architects right out of school. What I look for in a developer isn't that they know what an anemic model or the parallels between map filter reduce and functional versus C# link. What I look for is your apparent ability to learn. So take the time, have some pride in your code. There may or may not be issues at runtime down the line, but there may be. And there are definitely readability issues. Saying that the framework will optimize out spacing for you is no excuse. Those intern mistakes are a form of complexity hiding. Without using statements, you are hiding the fact that you have a disposable dependency and may even need a factory to make that dependency mockable. When you see multiple lines between execution, you are trying to communicate a logical separation of functionality instead of just making a semantic method to describe a piece of functionality. Indentation should expose depth, another tool that you can use to tell yourself that you should split code into semantic functions. Messing up indentation or ignoring it is another way to hide that complexity. Orphan variables and unused usings are the opposite. They communicate complexity where there is none. I frequently find 20-line methods that were too complicated for somebody else to refactor because of orphaned variables, and where that method could be refactored into 1 or 2 lines. Misspelling is just mean and useless. You aren't saving anything by purposely shortening a variable or method name. And later on, when I go to search for table row with Control F, but some are missed because it was named TABLROW somewhere, you now make me make mistakes. Many developers will profess excellence in math, algorithms, AI, UX, or other specific disciplines, but they come across as intern or junior developers because of how much time senior devs have to take on pull requests, trying to understand their messy code and fail the PR over and over for a lack of code pride. It is really cool that you've written an AI that can do math based on handwritten notes and even determine if there are issues with your handwriting. It is awesome. If I wanted to make an addition or a bug fix, how hard would it be for me to isolate where I need to do that, write tests, and make the tweak, without ever having seen your code before? This is quite the rant for somebody messing up indenting, but let's dig one level deeper. Every developer, junior and above, should have heard about dependency injection. As a junior developer, you should have heard it passed around and maybe seen an example. As a software engineer, you should be using it in daily life. As an architect, you should be setting up the systems of DI for all of your software and managing your reference architecture. As a system grows, you need to spend more time thinking about your dependency tree. If you're not careful, a service can eventually have 3 or more dependencies, or circular dependencies, or split so half your methods use one dependency and the other half use another. They look similar, but the code at the top left requires a reference to an assembly holding repository implementation. Also, you cannot mock the repository for testing. Similarly, you can't change which instance it is used during runtime. The code at the top right gives all of the control to the caller, which we call the root or the entry point of the application. That entry point could be called at startup, an API call, or during a unit test. The 2 paths you can take to deal with inversion of control are to follow solid principles, such as interface segregation and SRP, such that your services are small and have a limited scope. If you find that your constructor needs more than one dependency, you should consider refactoring to keep clean code. Option 2, just register some things in the IOC container and all of your dependencies and all of your services magically work. Of course, I'm being facetious. Using an IOC container is just another way to hide issues with code cleanliness, readability, and maintainability. It pushes errors into runtime instead of compile time. It makes you forget that you should be thinking about your dependency tree at all times. Where your dependency tree had plenty of code smells, you hid the complexity by covering them up instead of refactoring the smell away. Separation of concerns is not a difficult concept. There's code for the visible UI a consumer sees. There's code for handling communication from a UI to the cloud. There's code for business rules and business logic. There's code for data DTO and data access. And there's a database. It's not surprising that separation of concerns looks very close to end-tiered development. However, we don't have a UI UX master or a data master. We just have plain old Microsoft shop software engineers, you might say. And Microsoft has this cool tool called Web Forms that does all of the HTML for you, if you just subscribe to their idea that the term MVC, which they stole from real programmers, and if you throw away persistence ignorance so you can access data entities directly on your HTML ASPX page, and just, in general, ignore all the rules of software development. It's easy. Any developer worth their salt who ever worked in web forms knows it was horrible. Apart from breaking every rule of clean code, It also had no way to do dependency injection, instead requiring methods and controllers to instantiate concrete classes and leaving otherwise good developers to work around that by creating what we call today IOC containers, the most destructive tool in software development. Microsoft didn't improve much when they went to ASP.NET with Razor. There's still no opinionated boundary to follow separation of concerns, though at least the ASP.NET Web API controller system is dependency injectable from the root, if you knew how to hook into the lifecycle. And more issues blurring the boundaries with WPF, OData, Silverlight, and others. All in all, Microsoft has produced many highly opinionated frameworks that allow beginners to do easy full-stack development. Unfortunately, this full stack is more like a homogeneous blob of spaghetti. The way the code in these frameworks thrive is by tightly coupling everything to everything else, making small project development easy. In the process, they make it seem okay to throw out all the rules of software development. So when a developer of a new project purposely chooses to follow these patterns, they are either hiding the complexity of their system or allowing the complexity to be hidden by Microsoft. Compare these frameworks to Microsoft's Web API, Google's AngularJS, and others that stay in their lane. They take complexity and organize it, giving you more power to separate the concerns, opposed to those other frameworks that try to hide complexity and make things easy. What is a bounded context? Well, it's really the hero of the story, and it's the architect's job to manage it. When I say architect, I'm not talking about some guy with a big head who thinks he's better than you. I'm talking about the developer who is responsible for the reference architecture. That means if a developer tries to create or install a NuGet package, the architect better sign off on it. Not because he's some posh who thinks MOQ is better than MS Test. Leave those decisions up to a roll of the dice, for all I care. The architect should care about when an internal NuGet called company.cat.models is being referenced by company.order.data. The architect should be in a constant state of freaking out that your company is still in a monolith and doing nothing all day, every day, but tearing your code apart, worrying about bounded context. Bounded context refers to which implementation, it's this layer here, and which NuGet packages your code has access to. One common example is that your UI should not use database entities. That is a vertical binding, meaning there are constraints about the vertical layers that your NuGets are allowed to cross. Your data entities should only be used by a consumer, and your UI should not consume persistence. It shouldn't even be possible for your order service, assuming this is your order service, to instantiate the entities of your dog feature. The dog and order services are not the same vertical slice, and horizontal dependencies between two vertical slices should always pass through an SDK. So while a dog might consume an order SDK, which would allow them to come back into the API like this, therefore it'll have visibility into the order's models, it should never reach directly down into the order's entities or up into the order's view models or even across directly into the order's implementation. Also, dependencies should be limited as much as possible to one direction, or they should even be event-driven. Most of us out there are working in monoliths. I haven't traveled the world, but I have consulted from company to company, and I've seen enough to know that it is difficult for a company to break out of the world of monoliths. We all talk about doing test-driven development, stateless development, RESTful services, service-oriented architecture, etc., etc. But are we doing it? To get a contract a while back, I had to talk to the dev manager for a large company in Oklahoma. He was traveling, so it was a phone conversation. During that phone call, he probably felt like he was really drilling me with questions about service-oriented architecture, test-driven development, and specifically microservices. In my mind, I could tell he only knew the questions to ask, but not why he was asking them. But I was already traveling to speaking engagements about microservices at that point, so I knew my business. Not long after starting the contract, I was somewhat harshly pulled into the dev manager's office and asked what the hell I was doing. Why are there so many NuGet packages? Why is everything so small? Can you imagine the latency when you have to make so many calls to so many different services? And yet, their existing project when I arrived, which I was replacing, either timed out or took at least 5 minutes to do nothing more than log in. I had to put my foot down and especially point out that it was my microservice qualification that brought me on as the architect of this project. Not only did I quickly fix the issues with the existing application, but I completed the beta for their customer-facing portal, and it was beautiful. I say all this to communicate that I understand how hard it is to be the master of the code, to put your foot down when you're getting yelled at, and to make sure that we know what we're talking about so we can defend our positions. Understanding the concepts of this talk is just the beginning. What is a monolith? A worst-case scenario monolith would be a single project with thousands of classes in it. But the easiest way to define a monolith is by how you run it. If you want to run an application and you are literally running the whole application, even if it's split into multiple parts, it is a monolith. If you want to run an application and you are only running just a user interface, or you're just running a single API that represents just one feature of your enterprise application, then you're closer to microservices with a bounded context. One change that was made from the original monolithic mindset was a change to projects. That is, it's still one solution, but 100 projects in it, each with only 100 classes. Of course, everything is still referenced just about everything else, but it was split up. Also, of course, you still compiled and ran the entire application. The next level of change you might see is moving things into different NuGet packages. However, you're still running the main base root application, but the work has been separated out. This is a step in the right direction, but you've now made it more difficult to troubleshoot. To be specific, since there is no bounded context, everything references everything else, so you somewhat need to be able to step through the whole project, and you've taken that away by splitting it into NuGet packages. Of course, once you get bounded contexts set up, then the need to step through an entire project goes away. The next level of change is typically splitting executables. This can be called APIs, WCF, SOAP, or whatever else, but they aren't microservices because they still reference the same base NuGet packages. There is no bounded context. Again, you have just exacerbated the monolithic issue. Also, even though things are split up into different executables, you have to build and run it all locally. Because what are you going to do if you change a base package? You have to test the entire monolith before doing any pull requests. So in short, you are still in a monolith if you can't cut your system into a two-dimensional grid and clearly define the vertical features and their horizontal layers. At that point, you should be able to run each piece of the grid in isolation and not worry about the rest of the system. In the business, we call this finding the seams. Just like you would do if you were a tailor taking apart a pair of pants into its individual parts. As I mentioned, one sign that you're still in a monolith is that you can't run in isolation. You have to worry about other parts of the system and how they affect you. This is a disclaimer. Of course, nobody works completely blindfolded. We all work in the backlog with user stories and feature requests. We always communicate our plan and document things. At least we should. We all work in the same dev and test environments, and we all push toward production. It's because of this that we have multi-stage deployments and feature gating. I want to be clear that just because every individual should be able to work in isolation doesn't mean there isn't teamwork. There are joining points in master branches and communication points in user stories and other ticket types. I don't want to say this again, so I'm going to give an example. If you have ever heard of the idea that a developer should be able to go into a backlog and pick up any task and just get to work, that probably seems like a dream. And if you've tried that, you have surely failed. There's always some point in having to wait on somebody else, and you enter a waterfall pattern. Some people blame the process or say Agile doesn't work. But the issue isn't the process. The issue is a tightly coupled system. If you try to build an Agile team around a waterfall code base, it just simply doesn't work. That is the core idea behind Conway's law. Whether you're in a monolith or getting your feet wet with the bounded contexts of microservices, you may be moving toward a shared development environment. This means your application and/or services are all merged and deployed just like they would to production, but confined to a secure environment that can't access production data sources and which true end users can't see. With a shared development environment, you may find that the front-end development can be simplified locally because you have to run less code. And you can point your local development work to the always running dev services. Well, that's the dream. In reality, a shared development environment is very difficult to manage in a monolith. since your low-level packages have widespread effects on the whole system. At this point, if you make any changes to a low-level package and push those changes to the shared development environment, you will be breaking that environment for everybody but yourself. Assuming there are a dozen services running in the shared development environment, your change now has to be deployed to all of them, or some of them will go down. And if another developer is working locally, but only relying on one or two of those shared services, he will have to stop what he's doing mid-work and change his code to use your changes. It's very jarring. This is why most shared development environments eventually break down to virtual machines where each developer can run multiple parts of the system without interfering with others. So imagine this whole thing running as a virtual machine. Because of this issue, tools like Docker were created so every developer can work in a snapshot of an environment close to production without having to worry about manually spinning up all the services. Pause for Docker fans to cheer. But just as I covered with IOC containers, you are now hiding a complexity with a broken system architecture instead of fixing the issue. Docker, just like IOC containers, are band-aids that hide bad systems and allow them to fester. In my experience, this is simply because the developers using them haven't yet seen the glory of a proper microservice architecture. Docker claims that it makes it easy to work with containers. I obviously have beef with that. Containerization is a pattern. It's not an application that you download. It is already easy to work with containers if the container is a container. If you don't know how to containerize your code, i.e., if you build monoliths that you want to run as if you have containerized, then Docker is good. It's not good to properly containerize, but it is good to hide the fact that you don't want to do the appropriate work to properly containerize your code. A container is not a virtual machine. It is a bounded context. It is a good software architect constraining the reference architecture such that a piece of code can run in isolation. Docker allows you to have confidence that what you build locally will work the same way in production. Another way to do that is to program correctly with testing and feature gates. While I'm on the subject, the term serverless has also been hijacked by companies like Microsoft and Amazon as well. We should all know that serverless does not mean that there are no servers. What it really means is that your code doesn't rely on a machine always being up to maintain state. You don't buy a serverless. You program your code to be stateless and allow machines to scale down, horizontally and/or vertically, when you aren't using them. This is immediately available for app services in Azure. Let's imagine for a moment that we have some typical services: an order service, an inventory service, a payment service, authentication, etc. And we also have some unique business services like a dog microservice and a cat microservice. These services manage bounded contexts related to dogs and cats. They are both four-legged animals, but are different in every other way. Imagine we have built these microservices as advertised. Every horizontal and vertical separation exists, just like I talked about previously. Now imagine you want to troubleshoot a problem with the dog feature. The problem is your user interface is not showing a dog's tail length. A new front-end developer is assigned the task. They clone the web UI project. They navigate in the website to the dog feature portion of the website. They add a dog as a test, seems successful. And when they look at their newly added dog, it has no tail length property, just like the ticket says. Was it saved in the database, but it just didn't return it? Or maybe whenever you added the dog, it just didn't save it in the database. That's why it's coming back empty. They don't know. So at this point, many monolith developers' instinct is to build all projects in one solution so that you can step through to see where the failure is happening. A developer acclimated to separation of concerns would instead open the integration tests, probably Postman. They'd find the call to the shared development environment that their web UI is hitting, and they test it out. The front-end developer, let's say he sees that it passes. Not like a test says success or anything like that, but it successfully returns a dog to them. They dig deeper into their UI, and they see the JSON that they're expecting back, but it doesn't match what the JSON was in the integration test. It's slightly misspelled. So they fix it in their web UI, they test it again, and it's all fixed. Turns out the problem was in the web UI. Or let's say that the front-end developer sees that the test fails in Postman. So they wipe their hand of the issue, they assign it to a middle-tier developer, a domain developer. Now imagine a brand new middle-tier developer on day one gets this ticket. They do not have to clone the whole company's code. They only pull down just the domain repository for only the dog feature. Not all of them, not the whole thing, not have to clone a database. They only pull down this. They can see that the DTO between the data entity and the domain model that would exist somewhere on the back layer, getting close to when it calls here, the DTO, that it's not DTOing that property. Everything else is working fine, but when the entity returns from whoever did this feature, the entity returns with the tail length. The model has a tail length, but it's not being DTO'd. It's not pulling that from the entity into the model. So what they do is they run a unit test to make sure that the DTO works as expected. They pass the unit test, and they do a pull request. An added benefit is that pushing this code only affects the dog service. It's a bounded context. Authentication, payments, orders, and everything else is untouched. The website doesn't even have to be restarted or rebuilt. This keeps running, this keeps running, this keeps running, and if you're doing red-green or blue-green develop deployments or whatever, this can technically still be running whenever you do a deploy, but this is the only thing that's being affected, is just one service. Before I get too deep in the weeds here, I want to state my disclaimer again. We all work in the backlog with user stories and feature requests. We always communicate our plan and document things, at least we should. We all work in the same dev and test environments. We all push toward production. It's because of this that we have multi-stage deployments and feature gating. This should all exist during all of these scenarios I'm going through. And we'd like it to exist as much in a microservice as much as we'd like it to exist in a monolith, though it is more difficult or impossible in a monolith. But I will delve deeper into it in the section after this one. In this new layered perspective, if 12 developers are working on the dog feature, and one of them needs to push a change, what should happen? If they push a change to the dev environment, won't it break everyone else working against that dev environment? No, it won't. Not if you're doing a bounded context. So let's say there's a race. There's 12 developers, 3 in the data layer, and one of the data layer guys finishes his change. So let's say that one of them adds a column to an entity. The developer's local environment, he's only cloned this, he has no access to any of these other things. His local environment is configured to work only on the data portion of the application. He could be running an entirely new Windows boot up, but only have his tools installed. This and maybe SQL Server Lite, Visual Studio, all cloned just for this one project. This one data developer changes the data layer on his personal local branch and makes the changes to his personal local SQL Server. He writes any integration tests that he needs in the data layer to make sure that he can read and write from this new column on his entity. He builds the scripts, and he does a pull request before anyone else. So what happens? Well, the pull request is accepted, the master branch for the data layer is updated, and the scripts are run to add a column. They're run on the shared development environment. Are the other 2 data layer developers affected by this? No. They are also working purely in their local instances, their local machines with local SQL servers. When it comes time for them to finish their work, what they'll do is they'll take the master branch that has been updated by the first developer, they'll forward merge into their local branches, they'll run the scripts that the first developer created, and so they will now be up to date with that locally. They'll do any sort of merge conflicts that they need to do, and they'll make everything hunky-dory before doing their own pull requests. All the integrations test passed, everything's fine. But the important thing being, while they were developing, they couldn't care less about who got something out before them. It all comes down to when they do the pull request themselves. So are the domain layer developers affected? No. They are working in the domain layer, and they do not hit the database. The domain layer is tested using unit tests, which do not hit the database. Are the API layer developers affected? No. The API can be updated when necessary, but right now, nothing will break. Nothing has to be changed with the API hardware, the authentication, the logging, or any cross-cutting concerns. When a user currently hits the API that's deployed in the shared development environment, they're going to get back a dog and have no clue that an extra property was added to the database. It'll just work just like it did yesterday. There's been no changes. The current out-of-date data layer hitting the newly up-to-date SQL server doesn't care that there's a new column. It just doesn't pull it or update it. Are the front-end developers affected? No. They just consume the API. As far as they're concerned, since they're consuming that shared development environment, and as far as it's concerned, nothing's changed. So as far as the UI developers are concerned, nothing's changed. The only thing that's happened is a NuGet package was updated for the data layer, and the shared development environment's database has a property added to it. It's not a breaking change. So let's say during this race for changes, forget that last scenario. Instead, a domain person finishes some code. So they need to add a calculated property to a model. This is not something that's hit in the database. It's just a property on the business, on the domain model that will be calculated. They add the property to the domain model in a models NuGet library. They do a pull request. When that's done, they also update the domain services implementation such that when the database returns its current unchanged data, just as it has since yesterday, the domain calculates a few fields and fills in the value on the model. They do a pull request, and are the data layer devs affected? Definitely not. Data layer devs couldn't care less about any of the layers above them in any sense whatsoever. Are the other two domain devs affected? No. They are currently working in their own unit-tested code locally. When they're all ready to go with those other two developers, they'll do a pull request. They'll get master, they'll pull master, forward merge it into theirs. They'll make sure all unit tests pass, and then they'll do a pull request to check in their own code. Are the API layers affected? No. The API can be updated when necessary, but right now, nothing will break. Nothing has to be changed with the API hardware, authentication, logging, or any cross-cutting concerns. When a user currently hits the API that's deployed to the shared development environment, they're going to get back a dog and have no clue that an extra property was added. It'll work just like it did yesterday. Are the front-end developers affected? No. They just consume that API. As far as they're concerned, nothing has changed because the shared development environment feels like nothing has changed. Let's forget those scenarios, and let's say an API guy wins. Let's say of all 12 developers working, one of the 3 API developers gets some changes out. Let's say they changed the entire logging framework, the whole way authentication works, and altogether every single thing about the API. However, they ensured that the existing integration tests in Postman still pass, because all that really matters for an API is that the RESTful endpoints receive and return URL parameters, header parameters, the body, everything is expected. So they've changed all these different framework pieces, and they do a pull request, and they deploy it to dev. So the shared development environment has changed. So are the 3 data layer devs affected? No, like I said, they don't care about anything that happens above them. What about the 3 domain layer? Same thing. They don't care about anything that happens in the layers above them. So what about the other 2 API developers? No, they don't care. They're still working in their own local branches with their own integration tested code locally. When they're ready to do their own pull requests, they'll forward merge master from that other developer into their local branches, and they'll make sure that all integration tests pass. No negative effect at all. So are the front-end developers affected? No. They just consume the API that's described by Postman integration tests. As far as they're concerned, nothing has changed. The integrations tests in Postman still pass. So as far as they're concerned, their API stuff still works exactly as it did yesterday. So what about the front end? There's 3 developers working on the front end. Simply put, the front end can do whatever they want. Just as with the other layers don't care about anything above them, which means none of the other layers care anything about what the UI looks like or how the UI is consuming them. Are the other 2 front-end devs affected when the first UI dev checks in? No. When one developer finishes a pull request and their UI code is pushed to the UI in the shared development environment, the other 2 front-end developers keep working just as they had previously. In this scenario, the API hasn't changed at all. Of course, just as with the other layers, when the other 2 UI devs finish their code, they forward merge master, fix any merge conflicts, and do their own pull requests. Just to note, none of the second or third developers on any of those layers were ever interrupted during their own development. Now, this race was a bit rigged. Each of these developers seemed to be working in isolation, but let's spice things up a bit. Firstly, let me address the disclaimer I've hinted at a few times now. Apart from writing messy code, tightly coupling everything, and overall using tools to hide complexity, there's one other thing many of my clients miss altogether: feature gating. I've mentioned it multiple times already, but now is the time to delve in deeper. Whenever a team decides to add or remove a feature, based on the accepted stories in the backlog, they don't just go their separate ways and never talk again. There needs to be serious discussions to review the acceptance criteria, discuss the complexity, and make an overall basic plan. This could and should take days. One of the first things a team needs to consider is the feature gate. The team will definitely be hitting one or more layers, possibly one or more microservices, and of course, the user interface. After planning, a team needs to come up with the appropriate feature tags, permissions, or roles, depending on how you do your feature gating, and needs to put those in place immediately. Before any real code gets done, all appropriate configuration locations need to be preceded with feature toggle keys, and the toggle keys should be defaulted to off. This can and should be deployed through all stages, all the way to production. It should always be considered mild and low complexity and should always be an easy pass. Since they are only configuration keys and they are all off, production should appear untouched. Additionally, if the team decides some API endpoints need to be changed or added, the UI team member should use those feature toggles to determine if the UI should continue to work as it already has, or if it should switch any calls to follow the path of the new changes. This means the UI will ask the API if its feature is live. If not, the UI continues to work as it had historically, and if so, the UI will use the new API feature. Again, these are low complexity changes and should be tested and pushed through to master and production as soon as they are ready. Given that the team's features are configured as off, the application should continue to work as it has historically. Let's say data developer number 1 gets his code pushed and the database updated, which we determine has no effect on anything. Now let's say data dev 2 gets his code pushed and the database updated. At this point in the master branch, we have commit 1 and commit 2, and we have scripts for both feature 1 and feature 2. But the domain, API, and front end haven't been updated for feature number 1. However, they have all been finished for feature number 2. And now it's time to push feature 2 and all layers into the shared development environment. If you don't see it yet, our issue is that the changes for feature 1 are also in master. Uh-oh, let's run through our conditions and see what happens. At this point, the domain developer for feature number 2 has already entered the domain, pulled down the latest data core, the interfaces and entities, and ensured the DTO is up to date. This should not affect any other domain dev. Refer back to the part that I talked about earlier. And also at this point, the API dev has already pulled down all the NuGet packages, the data core, the data implementation, the domain implementation, pulled it into the API. Nothing else has to change for him. There's no new endpoint. The JSON models are simply passed through the API to the domain, and vice versa. Having added a property changes nothing for the API, other than having to update the NuGet packages. This API is already deployed in the dev environment at this point. As discussed before, the web UI devs already have the appropriate feature toggles pushed to the dev environment. If feature 1 is turned off, then it doesn't appear to have any changes. If feature 2 is turned off in the web doesn't appear to have any changes. But if feature 2 is turned on in the web, but feature 2 is turned off in the API, then the web looks like it has changes, but it's using mocked data in the UI. But now that the API is in dev, and the API toggle is on, and the web toggle is on, then the web no longer uses mock data. The web now has feature 2 fully operational, pulling from the API, feature 2. No more mocking. In the web UI development environment, this is where QA and other devs can go to test the UI along with the APIs. This is when QA says, okay, push to test. The code is pushed to test, possibly with all the features turned off. QA tests and sees that everything works just like it had historically. Then the features for feature 2, the toggles for feature 2, in the UI and API are turned on. QA tests feature 2 and says this works exactly like we expected feature 2 to work. At that point, you can immediately push to production. Even if you want to leave feature 2 turned off, you can push to production with it off. So I've not yet addressed the real issue. What about feature 1? Wasn't the data commit for feature 1 pushed to test and therefore to production? Yes, it was. The scripts for commit 1 and commit 2 were both run in the database and nothing. The feature toggle for commit 1 was never turned on. Nobody can access the changes in the API or the UI for commit 1. We really blew this out of proportion. There is no issue here. This was a tiny incremental change to the database and the data layer that does not affect anything. If anything, it makes it less work when we do decide to push the UI changes for commit 1 later on. And QA already tested the system with the features off and said that the whole system is working just as it did historically. We were sweating over nothing. Turns out there is no race condition for adding features. Incremental pushes are amazing if you have feature gating in place. You might now ask, this is just a column addition. What about a feature removal? This type of change is a breaking change. Long story short, it is exactly the same as a feature addition. But think of it as adding the ability to ignore a feature, or adding an obsolete attribute to a property on a model. If you feature gate your code so that while the feature remains on that you want to remove, it still works as it had historically. But when it is turned off, the UI and the code execution changes. Then we haven't really broken anything, have we? We have simply added a feature toggle and left it on so it works as historically, and made sure that testing turning it off makes it work as we expected when it's turned off. The only difference is at the end of the cycle, maybe a couple months later, you add a step to remove the code that is no longer being used since the toggle is turned off, and maybe delete some column or some table somewhere that hasn't been used in months. In short, a proper architecture with bounded contexts and feature gates will solve all of your development problems. The reason your code and processes aren't as agile as you want them is because they are tightly coupled and stateful. Agile processes, that is, processes that allow a developer to pick up any task and push it through to production as an incremental change, require an agile code base. I realize we aren't all working in the agile code base using bounded context and feature gates, but that's why we have brownfield development processes to find the seams and get us there without having to rewrite everything. Frameworks that are supposed to make development easy, like IOC containers, containerization platforms, and development frameworks like ASP.NET Razor, will destroy an application of any size. For more discussion, feel free to contact me or look forward to more videos. I'll see you all next time.